We now want to derive the relationship PV to the gamma equals C. And again, this is the adiabatic relationship for the pressure and the volume undergoing an adiabatic process. And again, in the adiabatic process, we have delta E int is going to equal the work done because Q equals 0. And delta E int is the same thing as NCV delta T, or dt, and our work is negative PdV. So from the ideal gas law, PV equals nRT, if I differentiate both sides, I get PdV plus VdP equals nR dt. And if I solve this equation for dt, I get PdV plus VdP divided by nR, and I can insert that in for dt in the first law of thermodynamics, and I get NCV times dt, but dt is now this, PdV plus VdP over nR, is going to equal negative PdV. So my n's are going to be able to cancel out, and I'm just going to be left with CV times the parentheses, PdV, and VdP, but I wrote it in this way because if I multiply both sides by R, okay, then over here I'm going to get RPdV, negative RPdV, and here I have CV PdV. So I have two terms that have PdV in them. So I'm going to group those together. All right, I'm going to group those two terms together. So I'm going to be left with CV times VdP, and then CV times PdV, plus, if I add this over to this side after having multiplied through by R, I'm going to get RPdV. So now I have PdV here in both terms, and I can factor my PdV out, and I'm left with CV plus R. But if you remember, CV plus R is the same thing as CP. Okay? So what this equation is saying is that the specific heat at constant volume times the volume times my pressure differential plus my specific heat at constant pressure times my pressure times my volume differential, the sum of those two numbers must be 0. Okay? So whatever is happening over here is going to be canceled out by what is happening over here. Whatever processes are happening at volume and my pressure changing are going to be canceled out by the processes that are causing my volume to change. Okay? And if I rewrite this equation, I'm going to leave everything else here so I can replicate this exactly. We have CV VdP plus CP PdV equals 0. All right. Erase the rest of this. And now what I'm going to do is divide everything by CV VP. Okay? So I'm just going to divide everything through by CV VP. If I divide both sides through, then I'm free to do so. And of course, on the right-hand side, 0 divided by that is going to stay 0. And that's pretty advantageous. So my CVs are going to cancel out, as are my V's here. So I'm left with dP over P. And I'm going to be able to cancel out my P's here. And I'm left with the ratio of CP over CV. That's where we get that ratio from, right? And I'm left with dV over V. And again, that side is also 0. So now I can integrate implicitly. Well, it's not implicit integration, but it's indefinite integration. So I just integrate both sides, okay? Then I'm going to integrate dP over P. I'm going to integrate dV over V, and I'm going to integrate 0. So this becomes the natural log of P, and this becomes the ratio of CP over CV, and I'm going to write that as gamma and the integral of 0 is a constant, but the logarithm of a constant is still just a constant. So we write this constant, since we have the logarithms on both sides here, we write this as ln of C. and it doesn't change the value, and ln of c is still just the constant that I get from the integration on this side, all right? Now, by the laws of logarithms, I can play a few games here. I can put gamma to the v to the gammath root by the law of logarithms, and that's perfectly fine to do. And another rule of logarithms is if I have log of p plus log of v, and it doesn't matter if there's an exponent here, log of v to the gamma, that's the same thing as the log of p times v to the gamma. And that's the same thing as the logarithm of c. So then if I exponentiate both sides, I just get p v to the gamma is equal to my constant, right? So whatever whatever processes are occurring, if they're adiabatic, the product of your volume pressure times your volume to the ratio of your specific heats is always going to equal a constant. And that's a very useful relationship, as you'll see with the homeworks. All right, so there's your derivation. It's not immediately clear how that relationship comes about and why it's true, but there is your derivation for it. So hope you enjoyed the videos, and I hope they're helpful for you for your homework.